Hey there, Year 12s. We're now moving on to example 18, which is still following from our previous example about Nor's investment. So remember, in this case here, we are now looking at compound interest with additional payments to the principal. So Nor's investment was $1,200. She puts it into an account that earns a particular interest rate, and then every month she wanted to add it on $50. Now here it says VN, where VN is the value of the investment after N payments have been received. Use your calculator to determine recursively the value of the investment after Nor has made 3 additional payments to her investment. So in my previous example, I have already accidentally done this myself. I'm just going to do it again just to remind you. So based on the recurrence formula, we can see that your starting value or principal V0 was $1,200. And then the recursive model tells us that we're going to multiply it by 1.0025 to the, I guess, whatever n value is, plus 50. So if I actually want to know the first 3 payments, right, then I already got V0, which is 1,200. So if I want to find V1, this is the same thing as saying V0 plus 1. So I'm following the formula here. N has to be 0 plus 1 gives you V1. True? Now, if I'm following the formula, then they say it's 1.0025. And since N is 0, then I'm now multiplying to V0 and then plus 50, which we know in our calculator, it would then be 1.0025 times 1,200 plus whatever 50 is, right? Now remember, we can do this over and over, but it takes a long time to do. And so what we do is we use this model by starting off and saying, I start off at 1,200, okay? And then you can then say times by 1.0025, okay? And then plus 50. See how it's different to actually writing 1,200 times 1.0025 and then add 50. I literally just typed times and it's followed on. Notice it says ANS. The ANS naturally picks up from the previous answer, and it said previous answer times 1.0025 plus 50. So now when I press enter and I press enter again, it naturally will take the previous answer and multiply by 1.0025 and add 50. So we can see the recurrence formula here, that after 3 repayments, I can see here, I'm just going to copy paste this section so that we can add over here. Here we go. So we can see that after 3 payments, you can see here V1, V0 was that, V1, V2, V3. So answering the question, I know, therefore, after 3 payments, because they asked after recursively find additional 3 payments to investment, what was the value of the investment? Well, the value V3 is equal to $1,359, and technically rounding it to 40 cents there, okay, to the nearest cent. Now, this is the recursive model. If you were to do it the long way, which you could have done, 1,200 times 1.0025 plus 50, and then you do 1,253 times 1.025 plus 50, that's your second payment, and then you do 1,306.1325 times 1.025 plus 50. You would have got the same answer, but you can see it takes longer, or you have to type more, wouldn't you? So that's why I'm trying to remind you that in recursive, you can actually use the pattern, and you just continually press enter, which you would have practiced in chapter 8. Okay, now let's have a look at B. Moving forward, and I'm just going to draw a box over here so we know this is the answer. So in part B, what will be the value of her investment after 1 year? So after 1 year, that tells us that there are 12 payments in total. True, because after 1 year, there are 12 months. And so that means there would have been 12 payments, or at least 12 times that she has added $50 into her investment. So what I'm really looking for is V12. That's what I want to know. Okay, so this is the long way of doing it before you actually use the finance solver. But here we go. If I were to do this again, we started off with 1200, and then we said times by 1.025. Add 50, so that gives me 1 year, 2 years, 3 years, 4 years, 5 years, 6 years, 7 years, 8 years, 9 years, 10 years, 11, 12. So that should tell me that this is my 12th year of payment. Okay, so here we go. Right there, that's getting into my 12th year of payments. And so, not 12th year, sorry, 12th month of payment. And so I now know V12, and that must be then V11, and that's V10. That tells me that V12 must then equal to $1,844 and I guess 82 cents. Okay, so that's how you would do it if you were to recursively add them all down. Obviously, you can do this faster using Finance Solver, and that is what we're going to be doing in the next few examples. Okay.